students. So here I have come with another episode on the chapter light. The topic is lens. Okay, if you missed the previous episode, then you can go back and can see all the episodes. I think your concept as well as the numeric problems will do. Okay, so that will be clear. Okay, and if you have not subscribed my channel yet, then subscribe the channel Physics Scholar, okay, to get all the update and information. Okay, and one thing I want to tell you that very short I will upload also some motivational videos, okay, how to overcome the fear of examination, okay, and how you can successful in your life, what should be the way to achieve your success. Okay, so that type of motivational videos also I will upload, so keep watching. And if you want any clarification regarding any topic, write it in the comments, okay, because your comments will inspire me to upload such videos more and more. And also if you want to get the notes, that also you write in comments and provide your mail ID, okay. So I will provide you the quality notes, okay, which will help you a lot during the examination. Okay, so without further delay, let us start the today's topic. We are considering the topic convex lens. Okay, images actually formed by a convex lens. Okay, so today the condition, the fourth condition I discussed in my previous episode. So two more conditions are there that I will continue here. So first condition is what? When the object is placed at principal focus on one side of the lens. Okay, so this is what? This is the convex lens. You know that. This is the optical center. You also know that. Suppose it is L dash. Okay, so it is optical center. It is F1. It is 2F1. It is F2. It is 2F2, like this. Here 3F2. Here 3F1, like this. Okay. So here this is the object now at the focus. Okay. So this ray will move to this path, that you know that if a parallel ray of light parallel to the principal axis after getting refracted, it will pass to the focus, okay, on the other side. And if a ray passes through the optical center, then it will move straight, okay, like this. Okay, so these two rays are parallel to each other. These two rays are parallel to each other. That means what? They will meet at infinity. So where the image, suppose it is AB, and the image will be formed at infinity, okay, where they will meet because the rays are parallel to each other. So the image will be formed at infinity where the ray will meet, okay, and it will be enlarged, okay, and it's the real image, okay, so it will be inverted. Okay, so what will be the position of the image at infinity? At infinity, what will be the nature of the image? Real and inverted. Real and inverted. Size of the image will be enlarged than the size of the, or more than the size of the object. Okay, so again I am explaining. So when an object is placed at the focus of the lens, okay, so this is the lens, so the object is placed over here. So one ray parallel to the principal axis will move to the principal focus, okay, after getting refracted by the lens. Another ray of light will suppose it will passes to the optical center, so it will move straight. So these two emergent ray or refracted ray will be parallel. That means they will meet at infinity. Okay, so the image of the object AB will be formed at infinity, and it will be real. Okay, and real image are inverted. So it will be real and inverted. The position of the image will be at infinity, and the size of the image will be enlarged than the size of the object. Means bigger than the size of the object. Okay, so hope this is very easy. Okay, and you have understood. Clear? Next, moving to the next condition. Condition means we are changing the position of the object. So up to this, what we have seen, up to this 5 position for the convex lens. What we have seen, all the images are real. Okay, when the object is at infinity, beyond 2f, at the 2f, beyond f and 2f. Okay, and it is at f. That means principal focus. Okay, so now next condition and the last condition, when the object is between the focus and optical center. Okay, when the object is between the focus and the optical center. Okay, so this is the lens, convex lens LL dash. It is what? It is O. That means optical center. So it is F1 just like before. It is F2, but it is 2F1. Okay. It is F2 and it is 2F2, 2F3, 3F1 like this. So the object is now placed over here. Okay. So one ray will come like this, and after refracted it will go through this, and the ray, suppose this. Okay. So to the principal, so to the optical center like this. Okay. So if the ray at the back, if we enlarge that at the back, so okay, so A dash B dash will be the image of the object AB. So see, these rays will be divergent in nature. That means what? They will be, the distance between them will increase as we move. Okay, the emergent ray that is coming out from the lens, that means they will never meet at any point. So they will be what? Divergent in nature. Okay, so if we enlarge that at the back, so they will meet at the point A dash. If we draw perpendicular on the principal axis, so A dash B dash will represent or will be the image of the object AB. Clear? It will be the image of the object AB. So that is what actually. So only this condition here, it is a virtual image. Okay, it is a virtual image. The rays are not meeting, but it appears to meet here. So the virtual image will be formed. The virtual image will be erect. Okay, virtual image will be erect, and it will form at the front side of the lens, where the object is placed. In that side only, in that position only, the image will be formed. Okay, virtual. So this is only the condition when the virtual image will be formed by a convex lens. What is the condition? The object needs to be placed in between the principal focus and the optical center of that particular convex lens. In that case, the virtual and enlarged image will be formed in the front side of the lens. Clear? So what is that? So suppose AB is the object placed between the focus and the optical center. Now a ray of light will passes parallel to the principal axis, will incident on the lens and refracted to the principal focus of the other side of the lens after getting refracted. This is the emergent ray. Another ray, suppose this is passing through the optical center of the lens. So the emergent rays of the other side of the lens will be divergent in nature. So they will never meet. So if we extend that at the back side, at the front side of the lens, the two rays, then they appears to meet at the point A dash. If we draw perpendicular on the principal axis, so A dash B dash will denote the image of the object AB. Clear? Now, what will be the nature of the image? The nature of the image will be virtual and erect, virtual and erect. Okay. Number 2, position in front of the lens, same side where object is placed, and okay, so it will be enlarged than object. Okay, enlarged than object. Okay, so these three are the key points to remember when the object is placed between principal focus and optical center. So it will be virtual and erect, number 1. Number 2, it will form in front of the lens. Okay, where in the same side where the object is placed, and it will be, the image will be enlarged than the object. Okay, enlarged than the object. Okay, so now what are the uses of the convex lens? What are the uses of convex lens? What are the uses of convex lens? So uses. So I will describe in later episode. Okay, what is long-sightedness, what is short-sightedness. Okay, that is there in the CBSE syllabus. Okay, so that also I will explain the human eye, the chapter. Okay, so after finishing this total. Okay, now first it is used to treat, it is used for the long sightedness. Long sightedness is a problem where the person is not able to see the object, okay, which is placed near to him. Okay, so that is long sightedness. Only the long object, distant object he can see. Okay, so that portion in details I will explain how we can correct these things. Okay, so that is used in the spectacle. Okay, for the person who is suffering. Okay, it is used for the long sightedness, or it is used in spectacle for the person suffering from long sightedness. Okay, so it is used in spectacle for the person suffering from long sightedness. Clear? Next, it can be also used as magnified glass. Why? Because if the object is placed between that means between focus and the optical center, okay, then what will happen? The enlarged virtual image will be formed. Just now I have shown that. Okay, so that's why it can be used as a magnified glass. Okay, so if we place it very near to the object, we see the enlarged virtual image. Okay, next, it can also be used as the glass of light show, projector, telescope, etc. Okay, so this type of lenses, convex lens. Okay, so these all are for convex lens. So these all are for the convex lens. Okay, so these are basically the common uses of convex lens. Okay, so it can be used as a lens of spectacle for the person who is suffering from long sightedness. Number 2, it can be used, okay, as a magnifying glass. And number 3, it can also be used, okay, in the as a glass of the slideshow projector or telescope, okay, etc. So these are the common uses of the convex lens. So this question is a very common and simple question that also can come, and you have to write these points, okay. So this is the convex lens, okay. Now we will learn the images formed by concave lens, okay. So now we learn the images formed by the concave lens, okay. So now we will learn the images formed by convex lens. Already we have learned, so it is concave lens, okay. So now it is for concave lens, okay. The first condition, when the object is at infinity, when the object is at infinity, okay. So let me draw the diagram. So this is what the concave lens